Now we've covered the basics of IP, let's go ahead and take a look at IP packet headers. Now again, IP does not have a lot of overhead to it, so its header is actually very simple. It has no flow control mechanisms, no windowing, no error correction, nothing like that. So it's a very simple packet header. It has a header and a data section. Data is the encapsulated segment or datagram that comes from above, from the transport layer. That's the transport header and any data that came from above the transport layer. IP doesn't care about that. Now, we have IP version 4, as you probably know, that is in common use on the internet today, and we have IP version 6, which is coming. Now, IP version 6 is not widely used in practice just yet, but a lot of machines, operating systems, and so forth are compatible with IP version 6. Now, we're going to focus more or less on IP version 4 for the purposes of our discussion. The IP version 4 header consists of 13 fields, and 12 are required to be used during a communication section. 1 is optional. We'll talk about that in a moment. Some of the fields you need to pay attention to include the version, the source and destination address fields, the protocol, and so forth. And we'll take a look at those right now. First of all, the version is normally going to be set to 4, meaning it's an IP version 4 header. Makes sense. We also have different fields such as header length, type of service, total length, identification, and so forth. One of the particular fields that I want to talk to you about is the flags and fragment offset. The flags will determine whether or not the packet is fragmented or not. A fragmentation flag can be set in these fields, and also you'll have the fragment offset. And the fragment offset basically tells you which packet is in which order, what fragment offset you need to have in order to put these packets back together. Now there's a time to live field as well, which basically determines how long that packet's going to live on the network. There's also a protocol field, which will tell you basically if it's an ICMP, IGMP, and so forth. Then we have the header checksum. The header checksum is a 16-byte field that basically checks the header itself and determines whether or not there are any errors in it. If it passes the checksum, it's great. If it does not pass, it gets dropped. This checksum does not cover data, which starts in offset 160. Now, two other fields that you need to be aware of are the source address and destination address. Now, those are the source and destination Internet Protocol or IP addresses, not the MAC addresses. So, when you're looking at a particular IP header and you need to know where this packet came from and where it's going, those are the two fields you're going to look at. That's what firewalls and routers also look at when making determinations about whether to drop a packet based upon source or destination IP addresses. Then we have the option field, which is optional, of course, and then our data. And again, the data field comes from above. That's everything from the TCP layer above, TCP header, whatever, or UDP. So that information in that field is what's left of the remainder of the packet, and IP normally does not care about what's in there. Now, just for kicks, let's look at a IP version 6 packet header. It's a little bit different, and we're not going to go through all the fields right now, but just understand that there's some things in common, such as the source address and destination address, but we also have a version field, and it will be 6 for IP version 6, a traffic class, a flow label, a payload length, next header, and hop limit are some of the fields in there. This is a simplified diagram, of course. Again, there are some differences, but there are some similarities as well. We're not going to go in depth on IPv6 for this session. Now, in the next session, we're going to look at a demonstration of the IP version 4 header, so you can kind of see what it looks like and how the different fields look when there's actual data in them.